Once again, I'm back with another important Kotlin concepts, and today I'll be focusing mostly on Kotlin object-oriented concepts. And without wasting the time, let's go right to the code, guys. And this is my IntelliJ IDE, and I will be writing you some code, not some code, many codes, and I will be trying to explaining you about some important object oriented concepts. Everything you need to know about the Kotlin object oriented concepts I will try to cover in this tutorial video. So guys, please follow my tutorial, and just let's jump right to the code. Okay, so what is the most important concept if you are starting about the object oriented concept in Kotlin? The most important fundamental concepts in Kotlin is called functions. Okay, so as you can see, the main is also a function, where it's like a root function where everything executes, right? Your program executes. But so let me create another function which is called function block. So what it does, sorry guys, okay, what it does, sorry for my spelling mistake. Okay, what it does, it's like it just prints out something like a values, it print out something, but it's a value. But also another interesting thing is we usually use this function to break our large program into smaller modular blocks. Okay, so this is, it's like a basic, it's a fundamental, guys. So it's like you use function. Why we use function? Okay, we use function block to break our large programs. If your programs is not only a one line of code, it's like a multi. When your project grows, you have a complex projects where you have a large programs. So how can you modularize your project? You can modularize your project, or you can modularize your class or a code into different blocks of functions, and this is a function block. Okay, and obviously the functions always start with the keyword function, with the name of the function, the parentheses, and like here inside the parentheses you pass your arguments. And it can you can pass like there are default values, like I want default value passed. Okay, so you can also pass a default value, so it's like a default value already existing there, right? And or you can pass a required parameters, like this is a required parameter. So it's like whenever you call the function, you have to pass this. It's so you have to compulsory pass this value. It's like it's something which you have to do it. You like, it's like it's required. Okay, and obviously your function also can have a return type. Okay, so this is the return type. For the moment my return type is boolean, so I have to obviously return true, right? Return something, otherwise like I will have an error. Okay, so this is a simple construction of your function block. Okay, having a keyword, the name of the function, the return type, the arguments passed. The arguments can be default or the required one, and you print something. So I want to print as default values and the required parameters. So let me call the function from the main function. So function block, I don't pass any default values, but required parameters I have to pass it. Default required params passed from main. Okay, so if I run this function, if I run this program, like this is a main function which runs this program, obviously it's going to print out the, you see, default and the required parameters passed from the main, as you can see here. So this is it's a fundamental of this is a starting point, guys. So breaking your programs, large programs, into smaller functional modular functional block is the most important concept. So I would like you to always modularize your program. Don't write small large chunk of code, okay? Just try to write small chunk of modular functional blocks so that it is more understandable, and also try to always name your function with the action, right? Like for example, you try to name it in such a way so that the programmer can easily understand. Name the function with its action. So that means just try to name the function in such a way that what it is doing, what is the function doing, what is this function doing, what is the function's function actually, so okay guys, so this is a function. And now I would like to also give you the introduction of another important function, which is a function without a name. It's called lambda function. And this lambda function actually doesn't have a name, but it has an input parameter, and also like the it has also the return type, which is a int, and which is always notated by this which is notated by this curly braces, you see here. Obviously I'm getting the error because I'm not returning anything, because the return type is a int. So I have to obviously return something. I have to return into 2. Okay, so what it's doing is taking input, which is an integer, and just returning a output which is of type integer, right? It's a simple lambda function. A lambda function always do not have a name. So just like this is a normal function which has a name, arguments, and the return type. Just like lambda functions, they don't have a name. You see here, like it's pretty much like I'm just assigning this lambda function to a certain value, like certain variable, but actually this is a normal lambda function. And pretty much you can print this value lambda function, but obviously you have to also pass the level, that is I want to my level 32. And if I print out like okay, let me comment it out. So guys, let me write it in a string template. My level is obviously this is a lambda function, so I have to write it in a string template like this. Okay, so let me run it. So you will obviously your level will be printed, and it's a 64. It's a double of whatever you pass here. This is a way of implementing your lambda function, right? So okay, it's all about the function. I discussed about the normal functions, I discussed about the lambda functions, and so lambdas is like also expression, you can say. It's not a function, it's like an expression that makes a function like it's like an expression. Okay, it's pretty much, it's not like okay, it's pretty much like different from the function, because it's like kind of an expression, so this is kind of an expression. Okay, so we also have there is a different kind of function, which is like a higher order function, another different fine. So higher order function. Okay, so I discussed about normal function, lambda function, higher order function. So what is a higher order function? The function that takes another function as an argument or return a function. as a return type, you know. So this is like is a higher order function. So higher order function is like one step ahead, like one step more. It means like you have a higher order function which take another function as argument. You see, it's like pretty so let me take a lambda function as input. You see, this is a lambda function which is taking string as a input, and also it's outputting string as output, right? So this is a higher order function. Okay, what it returns, it transforms the message. Okay, you see, it's returning the it's taking lambda function as an input arguments as lambda function, and also it is returning as output as a output return type as a lambda function. So it's also output is also a function, and also input is also a function. So this is higher order function, guys. Okay, so okay, so let's use let me explain you how to utilize this one. So what is the use case, okay, of this lambda function is like function using higher order function. So I'm using this higher order function. How can I use it? Is transform messages in equals to higher order function, which is taking a message. This is my message. I want to transform this. Okay, and you call my transform, but I have not used my transform, like I haven't still created my lambda function, because this is transform is like the lambda function, right? I have to create my lambda function, like, well, my transformer, and this transformer actually will transform the string, and it will output the result as a string, right? So it is pretty much input, and it will reverse the whole entire string. Okay, and yeah, so this is like my transform. Okay, so I would like to use transfer higher order function. Okay, let me use this transformer. Okay, it's like I'm not able to use it because I'm outside the okay, so sorry guys, my transformer. Okay, I forgot the comma. Okay, actually you can also use it outside because still visibility available there. Okay, so and yeah, what else, like so I have a transform message. Okay, and okay, so I can print out the transform message. Okay, and I can pretty much call this let me comment this out. I want to print this using higher order function. So I am calling this. So what you will do, it will uh, transform this message and print it out. So let me run this, guys. And the transform is done as a reversed format. You see, this is reversed. The message is reversed, you know. And this is it. This is how to use the higher order function. So there is also another way of using the higher order function, which is like using uh, like I want to use a higher order function using a reference named function, not using the lambda function, right? I want to use named function. Okay, so if my named function will take the input, obviously, because I want to transform the string, but this time I want to drop drop last 10 characters, you know, from the string. And how can I use like you see, your higher order function was taking the input, the argument as a function, right? You not only can pass the lambda function, you can also actually pass the normal function, okay, like a named function. Okay, this is like actually normal function. Okay, so this is a normal function. I want to use a normal function in my transformation, like in my higher order function. How can you use it? Normal function, function transformation. So higher order function is taking a message. I want my message to be transformed by using normal function. Okay, so how can you use a normal function? You can use a normal function by passing the reference of the normal function. You see, just the reference here by using this double this symbol. Okay, and then pretty much print out the normal function transformation. Okay, it's pretty simple, guys. So if I run the program again, okay, pretty much I want to do print ln, so so that I can just differentiate. So guys, okay, let's run this. You see, like message to be transformed by using normal function. So it dropped the actually the first 10 characters, like these 10 characters, you know. You see that I want my this is missing, so it dropped the, can also drop last, so I can also drop the last one, not the first. As you see, it's dropped the last 10 characters from here. Okay, so guys, so this is the introduction of different kind of function. Okay, I talked about main function. Okay, to summarize, okay, I talked about a normal function block. Okay, I talked about the third one was okay, just let me name it by number. The third one was a lambda function. The function, guys, I'm typing pretty fast. Okay, so even the computer cannot. Okay, lambda function, I have a higher order function. Okay, so I explained you about all these kind of functions, right? Okay, so there is also another important function. Still now we have a lot of functions in Kotlin, guys. So and the final function is called extension function. Okay, so this is a final function that I will be discussing in this tutorial, and this is what you all need to understand about function. So what is the extension function? Extension function is a function which is like add functionality to your class already existing classes. Like for example, Kotlin already provide string classes, right? Like for example, if you go out to the string, it's like a class provided by our Kotlin library. You see the package is inside the Kotlin class, represents the character strings, all string letters. So you can write extension to the already provided classes provided by your Kotlin library. So yeah, we can just write an extension function. So how to write a extension function? Okay, writing extension function is pretty easy. You just type the data type of uh, uh, the extension function that you want to write, and then you just write your extension, like providing the dot, and I want to drop last with the reverse. So I want to do some kind of a, in the string, whatever string, I want to drop the last with reversed. Okay, so I want to reverse first, then drop last two letters. Okay, and yeah, so this is a simple extension function. I want to utilize function using extension function. So I want to use this extension function. How to use it? Okay, so val is input. I have this I want to drop my last words, but first I want to reverse my input string, guys. Okay, so I want to do this, and it's pretty simple, guys. You just need to call this one, like I will just do it so that you will understand easily. Output, I can do pretty much like okay, I can do it in different way. Put equals to input, drop last with reverse. You see, you can call this extension function easily in the string. So see, so it's like such a lovely thing. Like, so you can print out the output. It's pretty simple, guys. So I will print it out. Extension function. So if I run this code, you will get a view okay, okay, with the reverse. I print out, but I'm not getting anything, guys. Why I'm not getting anything? It's because actually it's not returning me anything. It's not returning me as a okay, actually it's returning in, it should return the string. Sorry guys, it's my mistake. Okay, so now we have the reversed, we reverse the string, and then we drop the last two letters. Okay, and we reverse the string and then we drop the last two. Yeah, it seems like it's working. Actually also be careful, like as there was a mistake here, like you also have to use the return type. So you just return the string in the, like, doing your transformation, so that's it. It's all about, like, I'll talk about all the important types of function that you need to know in Kotlin, right? And I guess we are done with the function, guys. So pretty much we are done with the function, so I will just close my chapter of function. And okay, I would like to open an important another chapter, which is of class. We are trying to open a new chapter of a class. So what is a class? Actually, class is a is the blueprint. It's like kind of blueprint of object. So blueprint of objects. So that means you can create multiple objects with this blueprint called class. Okay, so it's pretty simple to create a class. Well, let me create a class called car. The car has a color red. The car has a price. Let's see, it's 2000 euro. And okay, let me create my class. Okay, and okay, so and what else? Your class can have yeah, I have a class with these two attributes. So the class has a keyword class, the name of the class, the attributes of the class. Okay, so and you can actually have constructors, or also like you can declare some primary constructors like color, string. So these are kind of a primary constructors. Okay, and or you can contain a constructor without any parameter, like meters. So constructor with no parameters, like this one, like you see, like yeah, my constructor doesn't have any parameters. Actually it's the same way of declaring here, right? So if you declare there, you don't need to declare here. So it's like this is a primary constructor. Okay, so you declare in two ways, as I told you, also here as a color string. So this is a primary constructor, right? And then what else? Your class can also contain some methods to perform some action, right? Like update my color of my car, new color, string, okay, my recent color will be a new color. Okay, updated. So this is a fundamental, like, so these are some fundamental concepts of the car. Okay, like my class, right? Sorry. And a class consists of name, and I already told you the body. So this is actually a body of a class. A body can also be optional. Okay, so so you can also not declare the body. Okay, it's optional. It's like it's not compulsory that you can have a class, like class my class without body. So I can just create also this class without body. Okay, my class has just only a constructor, like my attribute one, which is a string, you see, but it doesn't have any body, it's empty, right? I can also do that. It's not so compulsory that you need to have a body in the class. And also you can declare a class without the header, so without the type parameters, also this is not so compulsory. You see, I can only declare a class just with the name. Okay, so it's such a simple thing, guys. And um, you can do multiple things with the class, like your class can have a constructor with a parameter, like let me create a class which is okay to make you understand much better. Let me create my motor my size, okay, my cycle, okay. My cycle has a price and it has a color. Sorry guys, okay, so it has a body. Okay, so actually you can have also, and there is another interesting thing about in the class is like you can uh, uh, you can have also secondary constructors, right? So what are secondary constructors? Like I can create a constructor but just with the another parameter like name. I want my cycle to have a name, okay. And obviously if I create a secondary constructor, I also have to extend my primary constructor. I can have secondary constructor with different other parameters, like I can have multiple secondary constructors, like my cycle has a speed, and my cycle have a number, and you can also pretty much do some into number. Okay, so you can provide the price as a speed and number, you know. You can just pretty much do multiple interesting things here, right? Creating secondary constructors with multiple parameters, and also your parameters can also create like add the value to your primary constructor. So there are some I told you, first we have a primary constructors, and then we can have multiple secondary constructors, okay. You can just make more and more, it can be more and more like complex as you want, it depending on the class. And you can also initialize your, whenever you create a instant of my cycle class, okay, then you already automatically run the code in the init block. So this is run at least once, when you create an instance of the class. So my cycle color is a color, you can just print out this one. Okay guys, so so you can also actually have multiple init blocks, right? It's not necessary that you can have only, you can have multiple init blocks, okay. So it's not a problem. So you can have init block, this one, the another init block, you can just assign speed equals to like your price price equals to speed, no, speed is not allowed, but your price equals to uh, what I can do is I can you can initialize your price to be maybe minimum price to be 1000, right? Okay, sorry, but price is int, so okay, 10,000. Okay, so you can just do that. And yeah, this is all about the constructors, primary and secondary constructors. But actually guys, it's pretty much, i I have explained you, this is all the possibilities, what you can do with the class depending on the complexity of your class. But it is strongly suggested not to use multiple constructors like this one. It is pretty bad practice. Okay, so don't do that. And this can, because it can lead to issues while doing testing. When you write a code, obviously you have to do some unit testing of your code, right? And if you want to unit test your class, obviously having multiple constructors can create issues while testing. So please don't, I strongly suggest, as advice, not to use this. I have just explained you to give the possibilities that you can do, depending on the complexity of class. But it's strongly suggest to use simple constructors, primary constructors, and that's it. And not complicate your life. Okay, so this is it. And what else, guys? And okay, actually we can have also we can have, okay, so let me create a use my class. Okay, let me use my class. Let me use case of my class. So how can I use my class? I can use my class pretty much here. Where I can use it, I can use it my class here. So I create a object one. Okay, my class, okay, is object. My class actually has a compulsory parameter here, but I can also make the default to be red. Or actually, I don't need to pass because it's already by default here. So uh, okay. And what else like I can do is I can update my color. Before it was red, I want to make it blue, and I want to print the color of my object one class. Let's see. Yeah, obviously it's blue, but I want to also print before I update the class what is the color. So let's see. Obviously it should be red in the beginning and then blue in the first. So first color, updated color. You see the first color was red and then the updated color is blue, right? After I update. So you see, you can utilize your class, create the instance of your class in this way, and you can use the method to update the attribute of your class. And it's pretty simple of using the class, right? Using your class, it's pretty simple, right? And Okay, let's see what we can do more is okay, so we can go more about different types of class that we can have. We can have multiple different types of class. So what are the types of class? The first type of a class is called abstract class. So what is an abstract class? So abstract class is a class in which you cannot directly instantiate any abstract class, but you can only subclass and extend your abstract class. So actually abstract class is something like this. It always start with the keyword abstract class, and I want to my abstract class. Okay, abstract property. So your abstract class can have a property, and your abstract class can also have a tracked method. Okay guys, okay, print. Okay, you see, this is a simple structure of abstract class. I already told you cannot create the instance of abstract class directly, but you can only extend your abstract class with some other subclass, you know, so like in okay, let me explain it much better. You can not instantiate the class like a normal class, so you cannot create the instance. Like for example, you see, you cannot create like this, you know, you see it's error. You cannot create an instance of abstract class, you see that what I was explaining you. And but you can your abstract class can be used by other classes like normal class, like for example like my class can extend my abstract class. But to use my abstract class, obviously it has to also override you have to implement the members, that abstract property. So you have to use the abstract property, and that's it guys. So I have to use my abstract property, and I have to assign it to some certain value. Okay, let me make this abstract property as a value 123. Okay, and yeah, this is a simple way of using abstract class, right? uh, and now you can also actually, okay, let me use my abstract method also. So how can I use the abstract method? Object, no, I cannot directly assign my abstract method here. Let me see with the instance. But what I can do is I can create another method using abstract method. I can use Okay, you see I'm using the abstract method here. So if I call this method, okay, I'm calling abstract method but utilizing the object of this class, object1 dot abstract, using abstract method. You see, calling abstract method, but I see you can also use directly call abstract method here. You don't need to create another instance. Yeah, so you don't need to actually create another abstract. You can pretty much use the abstract method directly. Okay, and you can also use the abstract property. Okay, let me see. Yeah, okay, so you cannot directly use the abstract class's properties and method, but you can indirectly use it by extending this abstract class with your like your class, that you are using this class. So this is the first type of class, which is abstract class. Okay, let me write it here. Okay, so this is the first type, guys. What is the second type of class? It's pretty simple, guys. It's used most of the time. It's called data class. And data class is pretty simple. You just need to use the keyword data class, and name of the class is my data. Your data has attributes, but whenever you create a data class, it's compulsory. If you see, it's compulsory to pass the at least one primary constructor parameter. So at least one primary constructor parameter is the name. At least one you have to pass it. Okay, so but you can pass multiple, but at least minimum one, maximum as many as you want. Okay, and you can okay, so let me use this data class, right? Okay, but first I want to comment this out. Okay, and I want to use the data class, my data class. Okay, so actually you see it's a compulsory parameter. So my name is Run. Okay, but you can also actually pass the data class as a default parameter also, right? So that you don't need to assign here, and then print out my data. It's pretty simple, guys. This is the second type of data class. So what is the specificity of data class? You see my data, it's printing the entire class, but I want just the name and assign the values. So what is the use of this data class? This class is used to store a set of data. So in the in your program, like you want to store some different models of your class, then you can just use a data class to store your model or set of data. Okay, so it automatically, what is the use of this class is like it automatically generates getter and setter property. Okay, so you don't need to create it by manually, just like in Java we had to do it, create the getter and setter property. And it also generates the toString, the equals, hash code, and copy methods and everything. Okay, so there are also another interesting, let me give you some tips, guys. There are some data class which is it's already provided by our Kotlin library, like my peer data class. It's peer So this is also automatically data class, which is first and second. So this is a peer data class, okay, which is already provided by Kotlin, and which you also have a triple data class is triple, yeah, first second, the third. This is a triple, is a C. Okay, you can have also peer or triple data class. It's already provided by Kotlin, as you can see here. Peer is a data class, and let me check out if I can find the triple. Yeah, it's also a data class. As you can see, it's provided automatically by Kotlin library, so it's pretty simple, guys. So this is a tips for you guys. And what else? Okay, we covered abstract class, we covered our second class is called data class, and we have now the third class type of class is called enum, which is also mostly used. And let me create a enum data class, no, sorry, enum class. And enum is used to my enum type is actually used to represent your types, right? Different types, like I can have a different color, right? I can have a different types of fruit, or I can have a different types of car, right? For example, I can have a car called BMW, which is of color black. I can have Ferrari, which is of color, sorry, color red. I have Lamborghini, which is of color yellow. Sorry guys, yellow. Okay, so yeah, this is a simple way of creating an enum type. And we can use this enum. How can we use it? We can use it okay, let's me create a type okay, so what I can do is when object1 dot type, you see I can now check it with different type. Is BMW. If it is of this type, then do this. If my enum is type Ferrari, then do this. My is Lamborghini. I want to print the color. Color of this type, right? Okay, sorry guys. Okay, actually this is pretty much a repetitive code. Okay, you can do it in this way. Okay, so this is the way of utilizing your enum. You see the color is black actually because it's a PMVO. Obviously the type is by default PMVO. Okay, okay, so this is the second the third kind of a class, which is called enum class. And now I have another important class, which is called a singleton. Singleton, guys. So it's like singleton class, or also you can call it object. And it's very easy to create a singleton class. It's just you need to create an object. My object can be my object, the name of the object, and you can create anything like well my attribute a1, and my object can have a function like add. Okay, so you see pretty much it's you can create your singleton class in this way. You can create a singleton also instance, and then you can utilize this like done. Okay, single object is my object. Okay, okay, you don't need to create, it's already instantiated. And single dot yeah, you can assign like you can pretty much access the property of your singleton class. You can use the singleton class in this way, guys. So yeah, I can access the a1 value, that is 2 as a string, right? Okay, so let's move further. And we have also another interesting concept is yeah, I think this is all the types of a class that I want to explain you. So, and finally I want to also give you another interesting concept is like as I told you before, you can have primary or secondary constructors. You can also have a companion object. Okay, companion object inside your class. Companion object. And sorry, you don't need to pass as a parameter. And so what it is usually do is all the instance of class will share a single instance of set of variables or functions. So you can create a companion object to pretty much share the single instance of set of properties or methods using this companion object inside your class. Okay, like for example, you can have a constant like some constants value like value 1, you know, some you can have a size, the some certain size like of 100. You can have certain price which is like by default everywhere like 199, you know. Yeah, so you can just you can have certain property like methods like common method equals to price minus size, you know. So yeah, pretty much you can use this companion object to create a single instance of all your set of properties and method that is utilized everywhere. So this is the use of a so they are actually, this is a part of the real object here. Companion object is part of the real object. So whenever you create the instance, this is automatically created. Okay. Okay, so yeah, this is the is all about our class. So I already discussed about, we were able to discuss about different types of class like abstract class, data class, enum class, singleton object. Okay. And okay, so by doing this, I will wrap up my second section of this tutorial. This is about the class. Okay, so let's wrap up our this second section, and now I will jump to the another section, which is inheritance. So what is this concept of inheritance in Kotlin? So in Kotlin, we inherit our like we inherit, any class can inherit from its parent class, look, right? So the child class can inherit from its parent. So this is the concept of inheritance in Kotlin. So okay, let me explain it by creating a simple example. So let me create a class, parent class, which has a super value, which is 3. Your parent class can have a value super okay. Value. Okay, so so this is my super parent class having which is open, so anybody can inherit this class, and it has two one property and one method. Now I have a parent class. Okay, let me create my class, which is pretty much like inheriting my super parent class. So this is the concept of inheritance, guys. And here, like your super parent class is obviously can create you can override the super not really, actually you can not override until you have also access it as open, right? So let me override super value and override super method. So like your super parent class has two open methods. You can also have super closed value is, you cannot access this one, closed method turn super what it does is return so closed value, and which is of type int, right? Sorry, it's a function. Okay, and so as I told you, like we can have a open, your super parent class can have some open property and a method, or you can have a closed property and a method. So as you can see here, I cannot inherit the super closed method, so it's closed, it's pretty much close to the parent. But whatever is open, like you can pretty much access them, right? As I was able to uh, like inherit those open methods from the super parent class. My parent class is inheriting the open method and property of my super parent class. So this is the concept, guys. And pretty much now also, yeah, the same thing happens also for your child, my child class. But here is the same logic, the same logical concept goes also here. Everything which is open is accessed, otherwise not accessed, you know. But your child can also access the method of your super parent, like you see, like super value. Okay, super value is accessed, update super value is also accessed. So you can access the super value class um, and yeah, you can this is from super parent. I can also create the parent value, okay. Here also you can access the parent value. Okay, let me say it, open parent value, uh, closed parent value, okay. You see, parent value I can access, and I can override it, but I don't want to override my parent. Like, yeah, I can override and change my parent to my overridden parent. Open. Sorry guys, it's open parent value. Okay, so here I can override the parent. Okay, so you see the child now can access either from the like you, it's inheriting from the parent, but it's also the child can now inherit automatically what the also the parent is inheriting it, right? Also from super parent class, right? So this is the how the logic like how the inheritance work. The child can inherit from the parent or from uh, the super parent, where which is inherited by the parent. Okay, so this is all the concept works in this way. And yeah, what else I have missed with the inheritance, like, so yeah, the interesting concept that you have to understand is, if you want somebody some other class to inherit your property or method, you just have to use the keyword called open, and only in this way you can these properties can be exposed to other classes who inherit your class, right? So this is how it works, guys. And I think this concept of inheritance is pretty crystal clear. Now I would like to explain you some concept of interface. What is the interface? Okay, so pretty much we can wrap up this one, and inheritance is pretty clear. So let's jump to the another topic, which is called interface. What is an interface? So you can have a multiple interface, right? You can have an interface with this, create an interface with using the keyword interface and my interface. Usually your interface has it's kind of it provides the contract property and contract property and methods. Okay, so like color like a color string, like let me make it a string, like value. Okay, like is expensive, so this is a contract property that your interface can provide. You see, you cannot create the like it's an error. May not. So interface doesn't have a constructor, guys, so you cannot create a direct instance of your interface. It is just, it provides you a contract property, and you implement those contract property, right? So this contract property you can implement. For example, let me create a class, my class with interface. Okay, which is pretty much implementing the interface and obviously you have to implement all those methods. Sorry guys, you can implement those members, and it provides so you just implement your method. Your color of your class will be blue. The value of your this class will be like okay, 123,000. And if it is expensive, if value is greater than 10,000, 100,000, then it's expensive. Oh, it's expensive. Cheap. Return true, return false. Okay, you could have done it in a different way, like also this way, turn true or false. But it seems like it's we also have this one. So so okay, let's do it in this way. Okay, so yeah, you can use your interface in this way. And that's it, guys. I think I have covered enough for the Kotlin object-oriented concepts, right? And I hope I have explained enough. So these are the some of the interesting concepts that I've explained uh, from the programmer's point of view. So I hope you like it, and if you really like it, just thumbs up. And if you have any questions or queries, just comment below. And catch you in the next lecture, guys. Thank you.